Okay, this is part 2 of the investigation for 1.5, and it says to use the techniques that we discovered in part 1 to find the monthly payment for a 30-year home mortgage of $146,000 with an annual interest rate of 7.25% compounded monthly. So this is a loan, so we're going to use the formula U sub 0 equals 146,000. It's called the principal. That's the amount that we need to borrow. And the next year, we need the formula 1 plus 0.0725. That's what you get when you convert 7.25 to a decimal by moving the decimal 2 places to the left. Or another way of looking at it is to divide it by 100. We divide by 12 because it says right here that we're compounding monthly. So that's always a 12 if you're compounding monthly. This gets multiplied by U sub n minus 1, and then we need to subtract the payment. And the payment is what they want us to figure out first in this problem. So we're going to use the calculator to do this. I'd like you to turn the calculator on, go to y equals, we're in sequence mode. We're going to go ahead and put in the formula, parentheses, 1 plus 0.0725 over 12, close the parentheses, times second 7 will give us the u, parentheses n minus 1. I'm not going to put a payment in just yet. Instead, I'm going to go down and change u n min to $146,000. Okay? So at this point, we have the interest rate, the compounding monthly, the previous term, un minus 1, and the initial amount, $146,000. What we'll do next is we will go to the second window screen. That's your table setup. And the table start and the table change, that doesn't really matter. You just want to go down here and change this to ask. Okay, so we're going to use the calculator's table. We're going to put the independent variable on ask so that we can go to the table and we can see what the balance of this loan will be after 0 months. Obviously, that's $146,000. 1 month. And the amount went up because, remember, we didn't put a payment in yet. So we need to play around with different payment amounts so that this will start to go down instead of up. Here, the interest rate is making the balance go up or increase. But what we really want to do is see what happens after 30 years, and that's going to be 360 months. Now, this might take a minute or so. We have to, the calculator is figuring out how much money would be on the balance after 30 years, which is 360 months. And if you go and put your cursor right over top of that number, you could see that the balance on the loan is $1,276,000. So obviously, the $146,000 loan didn't decrease because we haven't made any payments. So what we're going to do is we're going to toggle back and forth between y equals, and we're going to go to the end of the line here and try out different payment amounts. For example, what if we did minus 400, meaning that we're putting a $400 payment on this loan every month. Now when we go to table, which is second graph, let's see what the balance is now after 30 years. You can see here, if you go over top of that number, the balance is at $763,000. So still, the amount that we borrowed went up instead of down. So we have to go back to y equals and increase this payment again. To go to the end of a line on the calculator, you hit second right arrow. Let's change it, instead of $400 a month, to $1,000 a month. That's not out of the question for a person to pay $1,000 a month for a mortgage on their house. So let's see if this works. We changed it to 1,000. We're going to hit second table again. Let's go back and see if the balance has decreased at all after 30 years. So we're in the negatives now. So what this means is That payment of $1,000 was so high that it took the balance below zero. So $400 a month was too low, sorry. $1,000 a month was too high. So it's going to be somewhere in that neighborhood. You want to play around with different numbers in y equals. At the end of this line right here, try a number like $900 a month, $800 a month, and keep going and try to get this number on the table as close to zero as possible, right in here. So as you change the amount, let's try to get that to be zero. Once you do that, you could finish part 2 and answer the second part of the question, how much do you actually pay for the house? So let's pretend for a moment that $1,000 a month was the right number to use. So imagine if we paid $1,000 a month for 360 months. How much money would that be total? It's going to be the 36 with 1, 2, 3, 4 zeros after it. So if $1,000 a month was your mortgage payment, you would have ended up actually paying, after 30 years, $360,000 for that home. So what you need to do is change this 1,000 to whatever number you find that works out for this problem. So I hope you get that. If not, feel free to email me or put a comment on the video. You could ask a friend, or you could wait until Monday or the next time we meet in class, and we will discuss this.